Alright, this one's kind of tricky here. We got number 34. If A is the set containing 1, 3, 5, 7, 31, so we look at that right away and we see that's the odd numbers between 1 and 31 inclusive. And T equals 1, 3, 6, 55 equals subset of triangular numbers. So what is a triangular number? Is where we can start. So triangular numbers get their names from forming perfect equilateral triangles. So we have 1, 3, 6, and as you can see, and this drawing isn't super good, but you just add 1 to the side length of each triangle and see how many dots you can fit inside the triangle, and that's where it gets the name triangular number. But if we draw one more, maybe this will help you see it better. So we'll do a triangle with 4 in it, right? So you do 4, then 3, then 2, then 1, and we have an equilateral triangle there, kind of. My drawing isn't super good. So that gives us 10. And so you can see essentially all we're doing is just adding another row. So we do 1 plus, and then the difference here is plus 2. And then here we add another row, which, maybe that's not the best way to do it. Plus 2, plus 3, and then we add another row, which is plus 4. And then you see, so we just keep adding on and on and on to make more rows to create these equilateral triangles. And so I think for this problem, the easiest thing to do is actually just to list the triangle numbers between 1 and 31. Well, I'll get back to that in a second, actually. So we need to say how many elements are in T intersect A. Now that's kind of a funny symbol there. So let's talk about sets now. So we know A, and this little bracket means this is a set. 1, 3, 5, 31. And B is the set containing 1, 3, 6, 55 equals triangle numbers. So, and I apologize, my brackets are just really atrocious sometimes. So A is the set containing 1 to 31 odd. So what is a set? A set is a bag. So we can say, here's our most simple set. This is the empty set, and a set can contain whatever numbers you put inside of it. And it can also contain other sets. So this is the empty set. This is the set containing the empty set. And so it's just a bag in a bag. But I don't think they're going to throw you anything super hard. So what can we do with sets? We have set A, and we have set B, and this symbol between them is intersection. And so for intersection, basically we have A, we have B, and we need to find out what elements are what elements are the intersection, or the elements of set A that are also elements of set B? So, I think the easiest way to do this is just to list out the triangle numbers. Yo, I'm teaching math. So to list out the triangle numbers, we have 1, plus 2 is 3, plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, plus 6 is 21, plus 7 is 28, and plus 8 is 36. So we know any triangle numbers that we have between 1 and 31 are going to be among these numbers. So we just need to count how many of these numbers are odd, and that will give us A intersect, oh, that is not intersect, A intersect B. So we have 1, 2, 3, 4, and A intersect B is equal to 4. Is that an answer? Yes. Now, for the bonus round. So this wasn't given to you on the exam, but it's very likely that you might run into this. So what we just did was A intersect B. You can also do A union B. Now, intersection, we know, is what is in both sets. Union is asking us what is in either set. If it's in A, it counts. If it's in B, it counts. So, in this situation, we have set A contains the odds between 1 and 31. So you can say that would be, so to get the number of odds between 1 and 31, you would do 31 divided by 2, and then you round that up. So that would be 16 elements in set A. Yeah, and if you want to count them all out, you can do that. But basically, that should work. Just because, odd numbers are every other number, divide by 2, and because we're doing 1 and 31, both inclusive, add 1, and I think that is correct. Now, for set B, I don't really know how many elements there are, so we can just count those right out. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, plus 5 is 15, plus 6 is 21, plus 7 is 28, plus 8 is 36, plus 9 is 45, plus 10 is 55. Now, what's important here, so we're solving A union B. Now, what's important here is that we don't want to double count any element of B that is also an element of A. So for any of these that are odd numbers between 1 and 31 inclusive, we need to strike them out, because if we count them twice, our answer will be wrong. So again, we have, Venn diagram. We count all of this once. We count all of this once. We count all of this once. So we'll cross out 1 and 3 and 15 and 21. And we're left with 1, 2, 3, 4, 5, 6 more. 6 more elements of B that were not elements of A. So we have 16 is the number of elements in A, plus 6 is 22, and that's equal to A union B. Now the way you can remember And I'll leave you with this one. So if you have two sets, set union, say this is set A, this is set B, union covers everything. So this is A union B, and you can remember it because the symbol for union is the first letter of the word union. A union B. Now set intersection. It's just the elements that are in both A and B. And that's pretty much all they can ask you about sets.